Lesson is the rational root theorem, and this will help us find roots to any degree polynomial. So, first we're going to start off with this value, and we have a constant term, and here is where we denote it as the p-value. So we need to know that p-value, and we also need to know this, which is the leading coefficient, and this is the q-value. The reason why we need to know the p-value and the q-value, it's because this will help us to find all our possible roots. So first we need to find a p-list, and the p-list, you guys, are basically just the factors. So the factors of negative 40 is plus or minus 1 and 40, plus or minus 2 and 20, plus or minus 4 and 10, and plus or minus 5 and 8. So these are all the factors of negative 40. Now we have to find all the factors of the Q list, which is plus or minus 1. So now what we're going to do is we are going to find our P over Q. And our P over Q, this is what we call your guys' possible roots. So this will give us all our possible roots, okay? So our P over Q is basically what we got to the left. So plus or minus 1, 2, 4, we're going to write in numeric order, 5, 8, 10, 20, and 40. And then our Q is just basically plus or minus 1. Now, it's going to equal, okay, so 1 over 1, which is plus or minus 1. And then 2 over 1, which is 2, 4 over 1, 4, 5 over 1, 5, 8 over 1, 8, and so on. So this list right here, these are all our possible roots. That's all of our possible roots right there. And we're going to keep on referring back to that list until we find all the roots for our polynomial. Alright, so now we have to use synthetic division in order to find our roots. Now remember, you have to go back to the polynomial and write down all the coefficients, which is 1, 3, negative 18, and negative 40. So 1, 3, negative 18, and negative 40. So now we gotta test a point. So there's my list of all possible roots. Now we have to pick one and see if we get a remainder of 0. If we get a remainder of 0 from using synthetic division, then we know we have a root. So I'm gonna pick 1. 1 times 1 will give me 1, 3, and then add, right? Mama. Multiply and then add, multiply and then add, multiply and add. So 4 times 1, 4, add, negative 14. 1 times negative 14, negative 14, and then we add, we get negative 54. So unfortunately, negative 54 is not a remainder of 0, which means 1 is not a root. So now let's pick another one. Let's go for negative 2 now. 1, 3, negative 18, negative 40. So I'm just picking a random one, but I feel good that negative 2 will be a root. So So let's see. Drop the 1. Negative 2 times 1 is negative 2. We add, which we get 1. Negative 2 times 1 will give us negative 2. We add, we get negative 20. Negative 2 times negative 20 will give us 40. We add, and we get 0. So we got a remainder of 0, which means negative 2 is a root to our polynomial. So now I'm going to put this in as a polynomial form. Remember, this root we just found, that's going to be the opposite when you write it as a polynomial. So x plus 2, and then we write this polynomial. So remember, constant, first degree, second degree. So x squared plus x minus 20. And all of this is equal to 0. Now, whenever you have a trinomial, then you either factor or you can use the quadratic formula. You factor or you use a quadratic formula. So I'm going to see if we can factor this. So on top, it's negative 20 times the leading coefficient, which is 1. So negative 20 times 1 will give us negative 20 on top. And then the one that goes on the bottom is your middle term's coefficient, which is the b value, which is just 1. So what times what will give you negative 20, but when added gives you 1? Well, that is going to be 5 and negative 4. Now, since your leading coefficient is 1, this shows us that 5 and negative 4 is our factors for x squared plus x minus 20. So x plus 2, x plus 5 coming from over here, and x minus 4, which is coming from over there. And all of that is equal to 0. Now remember, in order to solve for your zeros after this point, you set all these equations equal to 0. And then you solve for each one of these. So minus 2, x is equal to negative 2. That's 1, 0. Negative minus 5, x is equal to negative 5. That's another 0. And plus 4, x is equal to 4, which is another 0. So all of our zeros are x is equal to 2, negative 5, and 4. And there is your guys' answer for that first problem. So again, we use the rational root theorem in order to find our roots, and then we just do it from a polynomial, and look at that, we found all 3 roots. Alright, so moving on to example 2. Alright, so we're going to go at a little quicker pace now. So here's our P list, that's our P, and this one is our Q. So instead of writing P list, let's just write P factors. So P factors of 6 are plus or minus 1 and 6, right? 1 times 6 will give us 6, and plus or minus 2 and 3. 2 times 3 will give us 6. Q factors would just be plus or minus 1. Now what we have to do now is we have to find our P over Q, because our P over Q will give us all possible roots. So my P is 1, 2, 3, and 6, all over plus or minus 1. So P over Q is going to equal to 1 over 1, which is just plus or minus 1, 2 over 1, which is just 2, 3 over 1, which is 3, and 6 over 1, which is 6. So all of this is all our possible roots. Now again, it's like a game, right? which one of these is the root to our polynomial. Alright, so synthetic division time. I got 1, -1, -7, 1, and 6. So now we have to guess. Well, I always like to start small, so let's just guess 1 for now. Again, I picked 1, right, because 1 is a possible root, and I just decided to pick 1. You guys could pick whichever one you want from the possible roots list, but I'm just picking 1 for now. 1 times 1 will give me 1. -1 plus 1, 0. 1 times 0 will give me 0. -7 plus 0, -7. 1 times -7, -7. 1 plus -7 is -6, and 1 times -6 is -6. And look at that, we get a remainder of 0. Now here is a new technique to save us some time. You guys know you can stop when you guys get a trinomial. But we don't have a trinomial here. We have 4 terms. So since I know we can't stop and we still have to get more roots from our possible roots list, we have to pick roots out of that list. Let's just guess another one and use these new coefficients for synthetic division. So I'm gonna write 1, 0, -6, -7, -6. And now we have to guess another one. Let's just guess 2. Drop 1. 2 times 1 is 2. 2 plus 0, 2. 2 times 2 is 4. -7 plus 4, -3. 2 times -3 is -6. Unfortunately, I'm going to stop, right? Because we know that's not going to be a remainder of 0. And when it's a remainder of 0, that's when you know you have a root. So I'm not using that one. So 2 cannot be 1. I'll just put over here. 2 cannot be 1. Let's try -2 though, because we are really close with just +2. So -2 times 1 will give you -2. 0 plus -2 is -2. -2 times -2 is 4. -7 plus 4 is -3, and -2 times -3 is 6. And look at that, we got a remainder of 0. So we know 1 and -2 are our roots, and now we have a trinomial. So let's just put it in polynomial form. Okay, so remember, in order to put it into polynomial form, these ones on the outside are the opposite when you put it back into a polynomial. So x minus 1. And for this -2, to put it back into polynomial form, it's going to be the opposite, so x plus 2. And then constant, first degree, second degree. So x squared minus 2x minus 3. Constant, first degree, second degree. And all of this is equal to 0. Now we can factor out the trinomial, or we have to see if we can factor out from the trinomial. So remember, to get the top, it's the leading coefficient of that trinomial, which is 1, times the c value, which is -3. So -3. And on the bottom is the middle term's coefficient, or the b value, which is -2. What times what will give you -3, but when added gives you -2? Well, it's -3 and 1. And luckily, since our a value, which is the leading coefficient, is equal to 1, we just know these are just going to be the factors of that trinomial. So x minus 1, just rewriting these two, x plus 2. And now we have x minus 3, which comes from here, and then x plus 1, which comes from here. And all of that is equal to 0. Now, let's just find our 0. So x is going to equal to, from this one, right? It's going to be 1. from this one, it's going to be negative 2. From this one, it's going to be 3. And from this one, it's going to be negative 1. So that pretty much did it for our notes on rational root theorem. Now, in this next segment, which is below, I'm going to go over some homework problems. I'm going to teach you guys like some insight strategy on maybe how to figure out which one are your guys' roots from the all possible roots list. So let's take a look at this one. I'm going to drag this one down here to look. Okay, so this is number 15 on your guys' homework, okay? This is number 15. So like normal, gotta find your P factors and your Q factors. So here's my P, there's my Q. So P factors are plus or minus 1 and 7. And your guys' Q factors are plus or minus 1 and 5. And now we have to find our P over Q. So P over Q is going to equal to plus or minus 1 and 7, and then plus or minus 1 and 5. Now, this one's unique because this is the first time you guys are noticing that there's more than one factor in the Q. So this is how you guys go about it. Take these top, or the numerators, and put them over each denominator. So that's one denominator, the orange one, and this is another denominator, the green one, okay? So we're going to do purple over the orange one first. 1 over 1 will be plus or minus 1. 7 over 1 is going to be 7, plus or minus 7. Okay? So now let's do purple over green, okay? Now we're going to do purple over green. So we're going to have 1 over 5, which is 1/5. And 7 over 5, which is going to be 7/5. So those are all our possible rational roots right there. 1, 7, 1/5, and 7/5. And again, they're all plus or minus. I just put the plus or minus in front of the 1 so that it just represents for each one though. So, actually, let me see. Yeah, so there's our list. Now we have to go and find our actual roots. So I'm going to write down the coefficients. And we have 5, negative 46, 84, negative 50, and 7. So now let's try test 1. So I'm going to test 1 out first. 1 times 5 is 5, negative 46 plus 5 is negative 41. 1 times negative 41 is negative 41. You add it, you get 43. 1 times 43 is 43. You add it, you get negative 7. Negative 7 times 1 is negative 7. And look at that. So we found one root. But look, we have a 4-term polynomial, which is not trinomial, so that means we have to go and find another root. Well, gonna do another synthetic division, but this time, right, we're gonna just use these coefficients. Again, remember, the goal is to try to get our polynomial to be a trinomial. So right now, let's just try out 7. 5 times 7 is 35. Drop it down. Negative 6. Negative 6 times 7 is negative 42. Drop it down. Or we add. Get 1. 1 times 7 is 7. So It's a lot of trial and error, you guys, but I am just purely guessing at this point, but I'm just getting lucky, so hopefully I can show you guys some tips on how to do this faster as well. So look at that, we finally got a trinomial. So now let's put our polynomials, or let's put all of our roots and our polynomials into polynomial. So this one, remember, is going to be the opposite, so it's going to be x minus 1. This one too is going to be the opposite, so that's going to be x minus 7. And then we're going to put all of these as polynomial form. So remember, the 1 is your constant, this is going to be first degree, and this 5 is going to be second degree. So 5x squared minus 6x plus 1 all is equal to 0. Now, we have to factor out that trinomial, which is this one. We have to factor that out now. So using your guys' x method, so your a value and your c value, you multiply those together, so 5 times 1 is 5, which is on top, and then your b value, which is the middle coefficient, that's going to be -6, and put it on the bottom. So I know -6, nope. What times what is 5, but when added together it's -6. So I know that -5 times -1 is 5, but when added it's -6. Now look at your guys' a value, which is this, right? Your a value does not equal to 1, which means you have to use the x method further in order to factor that. So you have to write that term twice, remember? 5x squared, 5x squared. You have to write it twice, and then remember this one, you put it in the denominator, it's going to be -5x. This one, you put in the denominator, but it's going to be -1x. And now you guys have to simplify those fractions. So we're going to get x over -1, because top and bottom could be divisible by 5x, and for this one, you can divide an x from both. So it's going to be 5x over -1. So these are your guys' factors of that trinomial. So we're going to rewrite the polynomial. So x minus 1, x minus 7, x minus 1, that's coming from over here, and 5x minus 1, which is coming from over here. All of that is equal to 0. And now we find our zeros. So remember, to find your zeros, you set all these equal to 0, and you solve. So x is going to equal 1, x is going to equal 7, x is going to equal 1, and then for this one, to show you guys a couple of work,